The great physicist Wolfgang Pauli once said that if the Lord, or the devil, depending on which story you go to, allowed him to ask one question, he would ask, why 1/137? This is the fine structure constant, discovered in 1915, that combines three of the fundamental constants of the universe together to produce a number so apparently random, with no dimensions, and yet it holds the entire atomic world together. A number that has baffled physicists for the last 110 years, and in the strangest twist of all, marked the room in which Pauli died in. Welcome to the video. We're about to get unnecessarily Pythagorean. The collaboration between Carl Jung and Wolfgang Pauli is one of the most mysterious and fascinating in the entire history of quantum mechanics and analytical psychology. If you've ever tried to read Atom and Archetype, that's the collected letters between Pauli and Jung, then you're likely to have been completely and utterly blown away. What you're reading is something incredibly rare and unique. You have two titans in their field, both at their intellectual peak and both collaborating on a multidisciplinary problem, basically the structure of the universe and the shared structure, perhaps, between Psyche and the material world. It seriously does not make for light reading. And that's why, again, in my opinion, the hypotheses laid out by those two men on the Unus Mundus, on the archetypal basis of number, and all other kinds of topics remains unsurpassed to this day because of how niche and multidisciplinary it is. I've seen people in a more Jungian orientation say or implicitly let out that, well, you don't really need the physics side of things, you don't need the math side of things, you don't really need to dig into that. And they kind of claim that Wolfgang Pauli is like a precursor to the work that they've done. But this is a litmus test if ever you come across somebody like that. There are quite a few of them on the internet. Ask them, explain to me now the Pauli Exclusion Principle using the periodic table. And you'll probably watch their face go, because they won't be able to do it. And then you can turn around and you can say, you're not even wrong. That's what Pauli used to do. That's a famous quote from Wolfgang Pauli. He was famous for being a brilliant physicist, but also for being a sardonic Mephistopheles. If one of his students would get something wrong or propose an idea of some kind that he didn't like, was too abstract, too metaphysical, or didn't have the maths rigorous enough, he would utterly rip it to shreds, but always with a smile. Famously, too, he wrote to the famous Erwin Schrödinger of the famous Schrödinger equation and said, right, mate, enough of your Schrödinger's cat in a box. Nonsense. Stop being so melodramatic. So when you have Pauli and Jung, you have two serious personalities working together, and that's what we're going to explore in this video. Now, I think if you're here, there's a 99.9% chance you're way more familiar with Jung, to be fair, than with Pauli. That's the norm. So we're going to take a little bit of time to walk through who was Wolfgang Pauli and what were his contributions. But we're not going to skip on detail. We're going to go full physics, and we're going to bring in a little bit of maths too, because that's the essential groundwork for understanding Pauli's psychology before we then move into why the collaboration with Jung was so massive. And we'll also look at the unanswered questions still to this day that are extremely exciting. If you like these really deep dives, then you'll probably love what I'm doing with the Jung Project. That's a private podcast that I run once a week where we go through Jung's collected works, literally line by line, fleshing out as much detail as possible and also putting it in historical context. Because if you're anything like me, and you probably are if you are here, then these ideas are our heritage. I think it's really important that we go through them and bring them back up to the surface. If you're interested in that, there's a link in the description down below. So Wolfgang Pauli was born in Vienna in the year 1900, and he spent his teenage years doing things which teenagers don't tend to do. He dedicated himself wholeheartedly to the new maths and physics of the day. And of course, this was Einstein's theories of special relativity, and when Pauli was 15, general relativity. He put himself into this so far above and beyond that he published his first academic article when he was just 18. He then went off to university, and a great physicist in his own right, Arnold Sommerfeld, was his tutor and his mentor, and was immediately impressed by the young Pauli's ability to grasp this mathematics, this general relativity, special relativity, that physicists of the time, a lot of them, didn't really understand. So what did Sommerfeld do? He said, Jung Pauli, I want you to write a big monograph on relativity theory for an encyclopedia. I'm supposed to do it, but I'm too busy doing other cool things. Can you do it? Pauli did it. And when he was 21, he published this massive article, and Albert Einstein himself said, quote, whoever studies this mature and grandly conceived work might not believe that its author is a 21-year-old man. One wonders what to admire most, the psychological understanding for the development of ideas, the sureness of mathematical deduction, the profound physical insight, the capacity for lucid systematical presentation, the knowledge of the literature, the complete treatment of the subject matter, or the sureness of critical appraisal. It's very difficult to find higher praise from one Albert Einstein. Of course, this was an initiatory moment for Pauli, and he was ready at the age of 21 to tackle some of the biggest unknown problems in physics. Some years earlier, Ernest Rutherford had proposed his model of the atom. He said that an atom contains a positively charged nucleus, and around the outside are negatively charged electrons. This is taught literally up to GCSE level, or whatever the equivalent around the world is, still to this day, that you have electrons orbiting a nucleus. However, Niels Bohr came along, another very famous physicist, and said, hang on, wait a minute. If electrons are orbiting the nucleus, that means that after a while, they're going to be pulled in to the center, the atom will collapse, the world will end. And considering that atoms are generally stable, this probably isn't what's going to happen. So Niels Bohr, who was a big fan of Max Planck's work, the very earliest work we can say on quantum mechanics, took Rutherford's model, applied Planck's constant to it, and came out with his own updated model of the atom. Bohr's model limited electrons to only being within specific energy levels, and for reasons called valency that we won't get into here, he deduced that the first shell could contain 2 electrons, the second shell could contain 8, and so on. He had experimental data specifically looking at the first 2 elements of the periodic table, hydrogen and helium. This created a revolution in physics. But physicists being physicists always ask for evidence and for proof. And a lot of them said, well, why is it that the first shell can only contain 2, or the second shell only 8, and so on? So in 1915, Arnold Sommerfeld, again, that's Pauli's mentor starting a few years later, did a very similar thing to what Bohr did. Where Bohr applied Planck to Rutherford, Sommerfeld applied Einstein to Bohr. Sommerfeld's argument essentially went as thus: if you've got movement of electrons within space-time, then surely we have to apply the theory of relativity to that and make some corrections. So he did this using some experimental data we're going to look at in a moment, and he came out with this very strange number. 1/137. This is the number which we opened this video with. It's a dimensionless number which is literally, for some unknown reason, required for electromagnetism to have any strength at all. Here's the formula. Alpha equals E squared over H bar C. E is literally just the charge of an electron. H bar is Planck's constant, and C is the speed of light. So even without any mathematical knowledge, you can see you take these 3 fundamental universal constants, you interact them in that particular way, because they apparently do, and you produce this dimensionless number, alpha, called the fine structure constant, which value is approximately equal to 1/137. So what the hell is this constant? Well, think of it like this. When you shine light through a gas, or you look at the light that an atom gives off, you get these unique pattern of lines. You may have seen these before. These are called spectral lines. You can think of them as like a barcode or fingerprints that each element in the periodic table has. Each element is therefore unique. But if you look very, very closely at one of the lines, you'll see it's not actually one single line. You can split it into several very closely spaced lines. Tiny splitting is called the fine structure. It's like you zoom in on a barcode and you notice that each black stripe is actually made of smaller and smaller lines. So what determines how much splitting in these lines that you see? That is the magical 1/137. You have to just have this in the universe to determine how far apart these lines are going to be. Now, the real magical so-called thing about this is it is not derived from first principles. You cannot explain it. You can't use philosophy or first principles mathematics to come up with it. It's just there. And in that sense, it's very similar to something like pi. Why is the ratio of the circumference to the diameter of a circle 3.1415? Nobody knows. So this was the intellectual heritage which the 21-year-old Wolfgang Pauli was walking into. And Arnold Sommerfeld turned to him and said, hey, there's this very strange problem in physics. No one knows how to solve it. You, mate, you're the man for the job. This was a problem called the anomalous Zeeman effect. It's very similar to the lines that we just showed a moment ago, where you take an atom, but this time you put it in a weak magnetic field, and the lines basically start going a bit strange. Sommerfeld said, well, there must be mathematics to prove this. Pauli, your job, go for it. So Pauli tried, and he tried, and he tried, and he tried, and he tried for about 2 straight years, and he didn't really get anywhere with it. And if we're going to use Jungian language for a moment, he began to compensate for that. He started to spend his nights, although he'd been doing this beforehand, to be fair, but he started to spend his nights in some of the seediest possible bars out and around town, consume copious amounts of alcohol. He once said that 2 bottles of wine agrees with me wonderfully because then I start to become socially interesting. And he would more than likely sleep with random women, he said so himself, and would get into fights. It's not the best look for a physicist, and he began to feel that he had 2 different personalities, a physicist by day and by night, something you might find in EastEnders. We'll skip into some of the good stuff. So in hindsight, Pauli was missing an intuition because he was limited by the mathematics and the physics of the day. In short, at the time, there were 3 quantum numbers which described the behavior of electrons. The first quantum number was put forward by Niels Bohr and describes the number of electron shells. That's the 2, 8, and so on. The second quantum number was put forward by Sommerfeld, which describes subshells within those shells. The third quantum number, which we won't get into here, basically describes how electrons behave when put within an external magnetic field. Pauli eventually had an intuition and said, well, what if there is a 4th quantum number that no one's discovered before? And even more than that, what if no 2 electrons in an atom can have the same 4 quantum numbers? Pauli was right, and this was the basis of the very famous Pauli Exclusion Principle, the principal thing that he is remembered for today. We can explain this with an image. So this is hydrogen. This is the simplest element. It's got 1 electron. This, by contrast, is helium. This is the next atom in the periodic table. It has 2 electrons. And this is lithium. It's got 3 electrons. But hang on, wait, why is that electron higher up than the other ones? So Bohr, Sommerfeld, and other physicists not mentioned knew that this was the case. You could cram, for some reason unknown, 2 electrons into the first shell, but then it got full up for some reason. Nature goes, no lad. Any more electrons, you move it to the next shell. So we'll skip into the periodic table. This is boron. It's element number 5. It has 3 electrons in its outer shell, but hang on, why is that one in a funny shape? Well, basically, as you go along the periodic table, dum-de-dum-de-dum-de-dum, nature seemed to neatly and mathematically structure these electron shells. And Pauli had just discovered by accident, this had nothing to do with the anomalous Zeeman effect at all, why this is the case. No 2 electrons could have the same 4 quantum numbers. So we'll explain this. If we take hydrogen, this is actually really easy. You have 1 electron, no problem. But then if we move to helium again, this has the same first quantum number. That's the same shell, those 2 electrons. The same second quantum number. Both those electrons are in the same subshell. That's 1s. And the same third quantum number, but it's different in the 4th quantum number. 1 electron is, today anyway, called spin up, and another is called spin down, a kind of angular momentum. Pauli had just laid out how the periodic table worked. I'm not joking. Without Pauli, you can't do any theoretical chemistry, any atomic physics beyond GCSE level. So to this day, the Pauli exclusion principle is one of the foundational axioms of all of quantum physics. Pauli had proved himself to be a genius. But Pauli wasn't just a genius. He was also very fond, for some strange reason, of accidentally, simply by being in the same room, blowing up all of his mates' lab equipment. This was the famous Pauli effect, and physicists, his colleagues at the time, took this extremely seriously, even if they didn't necessarily believe it. Genuinely, Pauli would walk into a room, his mates are doing physics experiments, things would stop working or blow up. It's all very well not to believe in ghosts. You can walk around and be very rational. Oh, I don't believe in ghosts. They're for silly people and children. But if it's 3 a.m, and you wake up to a massive crash in your living room downstairs, you 110% believe in ghosts. I don't care what anybody says, you just do. I think this was what was going on with the physicists at the time. They were like, the Pauli effect, but also don't come in my lab. He was banned from a lot of labs. Don't come in my lab, because as soon as you come along, you're going to get rid of all of my grant money, simply accidentally. And this happened for a very long period of time across Pauli's life, right up until he died, basically. And he didn't have to be in the room either. He could be out strolling Hamburg or Copenhagen. He could be on the train somewhere, and he would report that he'd feel a rather strange, almost cheeky feeling within his body. And he would know that something had happened regarding the Pauli effect. And then his colleagues would then tell him at that exact timestamp, yes, everything blew up around us. And Pauli would find this really, really funny, because why wouldn't you? Anyway, back to the physics, and this is going to be our transition into his collaboration with Jung. This is extremely important. Up until the Pauli exclusion principle, you could visualize physics. So take Newtonian mechanics, for example. You can draw diagrams of it, of a ball being thrown and falling to the ground. Or even Einstein's theory of relativity, both of them. You can visualize this, the curving of space-time. But with the Pauli exclusion principle, it was so difficult for him to derive because you can't visualize, it's impossible for a human to do, the fourth quantum number. This fourth quantum number that Pauli came up with is a kind of angular momentum. It's called spin, or it was called spin shortly after Pauli discovered it. But it's not actually electrons spinning around like drunk people. If electrons were genuinely spinning, they'd be moving faster than the speed of light, and then all of physics would completely crash. They don't. It's called spin as a metaphor. So what is this fourth quantum number that applies to every single electron in existence? Nobody knows. Barely any time had passed since the Pauli exclusion principle that Werner Heisenberg, one of Pauli's colleagues, proposed the mathematics that is now quantum mechanics. He did this by introducing matrices, which is more formally called linear algebra, to try and explain a lot of the strange quantum stuff that people were discovering. And again, it's extremely difficult to visualize a matrices as being a literal thing within nature. You may have seen these things before. And then the following year, the equally famous Erwin Schrödinger proposed his wave mechanics, or more informally, the Schrödinger equation. He did this based on the work of Louis de Broglie, who proposed in 1924 that matter had both wave and particle-like properties. Schrödinger took that and developed mathematics out from that. And the second order differential equations, etc., that you see in it, and the probabilistic element that you have to introduce is impossible for a human to visualize. It does not apply to our logic nor our sensory perceptions. And this was an enormous, uncomfortable problem for physicists, including Erwin Schrödinger. Also in 1927, Heisenberg comes out with his famous uncertainty principle. And all bets are off at this point. The uncertainty principle states that for some reason, nobody knows why, but hey, this is the maths and the physics, you cannot know things like the energy and the momentum, or the position in space and time of an electron at the same time. Why? We don't know. It's also not because we have incomplete maths, by the way. That was proposed, but was then debunked. Niels Bohr enters the scene again and comes out with his complementarity principle. Now, this is starting to read much more like philosophy than physics at this point, to say that the properties of quantum systems, such as its particle or wave-like aspects, are mutually exclusive. You can't have both at the same time. But both are present within nature. It just depends on the observation style or the equipment that we're using at that particular moment in time. This reminds me a little bit of theories of consciousness, such as dual aspect monism. Two aspects, mind and matter, of some underlying monism that are there, but you can't see both at the exact same time. This is human psychology, rather cognitive to be fair, human psychology attempting to understand the quantum world, and can only really do so via these broad principles that otherwise we cannot really understand. It was around this time when troubles, or really hell to be fair, began for Wolfgang Pauli. He was still being a superb genius physicist. In 1929, along with Heisenberg, he proposed the basis of what is now called quantum field theory. And in 1930, he predicted the existence of the neutrino, based purely on the energetic properties of something called beta decay. In 1927, Pauli's mother committed suicide, apparently because her husband had left her for another woman. And then in 1929, Pauli married a cabaret dancer in a marriage that was unfortunately very unsuccessful. She left him within a single year. Pauli actually said, rather amusingly in one of his letters, that, well, if she would have left me for a bullfighter or something like that in an area I can't really compete, fair enough. But she left me for a chemist. A simple chemist. I am a genius physicist. Why has she done this? Pauli's life continued to take a downward turn. His drinking increased, and his behavior out in the nightlife also got significantly worse. One time he was thrown out of a window into the middle of the streets. And in 1931, his life had reached crisis point, and he decided to consult Carl Gustav Jung. Now, in 1931, Jung is in his mature phase, and he's spent pretty much the last decade, and will continue to do this for some while afterwards, refining the concepts that he'd been laying down in all of his work going back to the year 1900, his work on complexes. In particular, the work he laid down in 1912 in the psychology of the unconscious, in 1921 with psychological types, and other concepts like the persona, the anima and the animus, archetypes, the relationship between archetype and instinct. He was, in Jungian terms, circumambulating everything he'd already splurged out over the last few decades, and wanted to take his theory as deep as possible to see what was in there, and also to get other people to take him more seriously. So the story goes that in 1931, Pauli bursts in, obviously after booking an appointment, he bursts into Jung's office, his mansion in Kusnacht, and starts going on and on and on about all the strange dreams that he's been having. He would apparently dream of the famous Renaissance-era scientist Johannes Kepler, and that kind of almost alchemical style science of that period of time. And he would also have strange dreams featuring the number 3 and the number 4. He also told Jung about some of his core relational problems, which he said that he had for relating to women. Now, Jung, being Jung, decided that he didn't want to treat Pauli himself. So instead, he referred him to one of his students, a relatively new student actually, called Erna Rosenbaum. Now, why did Jung not want to treat Wolfgang Pauli? It was for research reasons. He wanted Pauli's dreams and his unconscious in general to be uncontaminated by him, Jung, so that later down the line, if circumstances were favorable, he could then study Pauli's dreams to see, well, what was going on that was so archaic and so irrational in the unconscious of a man who represented in the 20th century rationality. Why is this the case? Pauli wasn't particularly pleased with this. He wrote to Rosenbaum and said, "I am a man who has had more success academically than I have had with women, but I consulted Jung because, well, he's the other way around. He's had more success with women than in academia," which is absolute shots fired. Pauli was not in analysis with Rosenbaum for very long. For reasons lost to history, she had to leave and go somewhere else after 5 months. But Pauli then spent the next few months taking everything he'd learned from her and his extensive reading of Jung's collected works. It seems from his library that his favorite was Psychological Types, which he'd annotated all the way through consistently. He spent several months working on his own dreams. Then the following year, 1932, he reached back out to Carl Jung and wanted to work closer with him. Now, I want to pause here for just a split second because there's a lot of talk in these spheres of the internet these days about Jung either being an unethical man or an extremely monstrous, elephantine narcissist. So some people may be wondering, well, was it unethical for Jung to do what he did to Pauli, to palm him off onto one of his students? No, not in my opinion. No, he made sure that he was referred to a professional who was being supervised. But this is important to know before we move forward. Jung is very, very interested in the research aspect of his work. It is consuming him obsessively. And he knows, in terms of his own personal myth, that's where his life wants to push him towards. So when Pauli consults him in 1932, yes, Jung absolutely helps him therapeutically. There's no doubt about this. And Pauli's issues began to get better and better quickly and quickly and quickly. His drinking went down and his relationships with women began to improve, including a couple of years later getting married to a woman. And that marriage lasted for about the next 25 years of his life until he died. So there was some success there. But the collaboration between Jung and Pauli was, and Pauli knew this and wanted it to be this way, research. Here were two people at the top of their fields interested in the same things. And this is where things are going to get ridiculously interesting. In the course of his mostly self-analysis, Pauli had an enormous internal personality shift. He realized something which some physicists at the time had been championing, not in psychological language, but based on personal experience. Most famously, Albert Einstein, saying that you required intuitions in order to derive your scientific theories. Before this, Pauli was not convinced by this, nor were most physicists, nor are most physicists today. You use your logic and you use your data and you work through in terms of principles. But what Pauli realized, again, from a mostly self-analysis, was that he was, in fact, very one-sided, a Jungian term, meaning he was too focused on one aspect of his psychology at the expense of ignoring another one. If we take Jung's typology, which Pauli used as a core framework for this, Pauli was too focused or too identified with his thinking function, logic and rationality, analysis. That therefore left his feeling function, that function which allows you to make a gut feeling yes or no in an evaluative sense, more contaminated by the unconscious, further away and less developed than his conscious mind. This opened Pauli up to the possibility that different people view the world in different ways. He looked back across the history of science, the field which he felt obviously the most home in, and he realized, yeah, there was something irrational about some of the biggest discoveries that had ever been made, including his own. Kepler is famous for having a dream of the Ouroboros, the snake biting his own tail, when he was trying to work out the structure of benzene, 6-carbon aromatic compound. Mendeleev, the creator of the periodic table, dreamed, apparently, of all of the elements fitting themselves nicely into the periodic table shape. Very nice of the unconscious, takes a burden off of the conscious mind. And of course, Albert Einstein with his famous thought experiments, which are rather close in terms of what Einstein did to what Jung termed active imagination. You lower the threshold of consciousness, you allow images to come through, and you engage with them intuitively. Pauli therefore wondered, as did Jung, at what point in history did we move from a more irrational, sensory, imagistic-based way, or even a more mystical way of understanding things, towards the more modern, intellectual, hard, rigorous way of understanding the world. And for that, he turned to, again, Johannes Kepler, this Renaissance-era astronomer who Pauli saw as being a linking bridge between the old and the new. Kepler was absolutely a brilliant empirical scientist, but he was also entrenched very, very deeply in religion. And this might blow your mind. It blew my mind when I first saw it. Kepler explicitly says that there are things called archetypes. He uses that exact word, archetypes, within the mind of man. They were put there by God, and all knowledge that we derive from the outside world is not really coming from the outside world at all. You do your scientific work, you uncover a pattern within your set of data, and this corresponds to the inbuilt archetype, bringing a theory forward, allowing a correspondence between inner and outer, a very alchemical idea. Pauli probably came across this, probably from his mentor, Sommerfeld, who was massively into the works of Johannes Kepler. Rather strange, apparently, for a turn of the 20th century physicist. But he thought that the spectral line work, as we spoke about earlier, was the discovery of something Kepler was very interested in, the harmony of the spheres, the music of these spheres. In Kepler's book, Harmonices Mundi, he describes a clash that he had with the alchemist Robert Fludd. Kepler was convinced that there was a magic number that would unlock, or at least represent, the secrets of the universe. It was a very common thing, almost ubiquitous in the 16th, 15th, 14th century, going all the way back. He thought it was the number 3. The number 3, a masculine number, the Trinity. That was all you needed to understand the world. Robert Fludd, on the other hand, said, no, it's not 3, it's 4. 4 is the magic number, with the fourth element being the anima mundi, the feminine soul of the world. This was a lightning bolt for Pauli. Because what did he spend his formative years cutting his teeth on? Well, what eventually came to be the exclusion principle. Before Pauli, there were 3 quantum numbers, all you apparently needed to explain the atomic world. But Pauli needed to introduce a 4th quantum number based on an intuition. He went from 3 to 4. Just like the argument between Kepler and Fludd, is it 3 or is it 4 as the number that you need to explain the world? Being a very rational person, he did not move full mystical with this. Instead, he found it fascinating that he, one of the most rational minds of the age, was dreaming of the number 3 and 4, how to move from 3 to 4. He'd required moving from 3 to 4 in his experimental work, and there were these people 400 years ago, Kepler and Fludd, arguing over the number 3 and 4. And then if you consult the alchemical and philosophical traditions all the way back to the time of Plato, and even earlier, to be fair, to the pre-Socratics, there is this ongoing argument between 3 and 4. Now, to the modern eye and ear, it seems incredibly strange and weird, and to Pauli too, but through his self-analysis, he came to understand, well, perhaps there genuinely is some kind of correspondence between what goes on within and the world without, exactly as Kepler had proposed. Unlike most people who come across alchemical ideas, Pauli did not start projecting all kinds of metaphysical bollocks into it. Instead, he wanted to take things very seriously and very rigorously. An example of this is when he wrote to Jung and said, physics and psychology probably require a unified language. If this is true, if there is a correspondence between inner and outer, surely we should be able to find a unifying language for it, right? The example that he gave was to take a concept in physics, such as radiation, a radioactive nucleus. Now, alpha radiation or beta radiation is the emission of a particle specifically, depending on what type, from the nucleus, but at an unknown time. This again, we go back to Heisenberg's uncertainty principle, or more specifically to do with radioactivity, something called a half-life, not the video game, excellent video game, but something called a half-life, a period of time in which, yes, statistically, we're going to lose some particles from this nucleus, but we have no idea and we are incapable of knowing specifically when that will happen. Now, Pauli dreamed of a radioactive nucleus. He dreamed of it a few times, and this was something that he'd worked on himself. And he wondered to himself, is this literally me dreaming of physics, or is this being used as a symbol to represent something which is same in kind or same in form, like a mirror image to it, something pertaining to, as Jung would call, individuation. So he wrote to Jung, and they went back and forth about this. And yes, indeed, there do seem to be rather strong parallels between a radioactive nucleus and what Jung called the archetype of the self. The archetype of the self is described as being the center and the whole of the personality at the exact same time. And it will release bits and pieces from itself, archaic collective unconscious-based materials, out from it at an unknown and unpredictable time. Just like the nucleus, the center of the atom, at an unknown time emitting something from itself, and both do so from a high charge density gradient, energetically, down into a more stable or intended state. If a process going on within the unconscious can indeed be represented rather like a one-to-one correspondence by something in the physical world, then again, as Pauli said, surely we can find a unifying language. Pauli's favorite for most, if not all, of the correspondence with Jung was on the archetype of number, the form behind number itself. In particular, it seems the natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. And we're going to move tracks here, and we're going to go very, very deep into what Jung and Pauli did together. And we're going to begin with the concept of the archetype. Up to this point, again, we're talking the early 1930s here, Jung had defined the archetype essentially as the formal cause of an instinct. An instinct was something fundamentally biological that would provide an impulse or a drive to go and perform some kind of behavior fundamentally. Whereas the archetype was a separate but strongly related factor that would determine the shape that that instinct would take across time. Think about something like a bee building its honeycomb home, or as Jung describes in Collected Works 8, a yucca moth performing this ridiculously specific dance for reproduction one time in its life on one specific day of the year, despite never having learned it before. There was as if an innate image that carried out a form or shape for that instinct. But through working with Pauli, and this is really exciting, Jung was about to upgrade or update his concept of the archetype into what most people now will consider to be mystical, and therefore go, no, I want no interest in that, that's just silliness. or they'll go full metaphysical wacko mode and go, the archetype. No. In letter 49 of Atom and Archetype, Jung writes, quote, "The archetype represents nothing else but the probability of psychic events." What in Christ's name does that mean? To understand it, we have to turn to physics, because Jung was taking this from his collaboration with Pauli and very interested in, say, the uncertainty aspects, the probabilistic aspect of quantum physics. One of the implications, rather unfortunately, of quantum mechanics is probability seems to be a law of the universe. Famously, Einstein said, no, it isn't. God does not play dice with the universe. Schrödinger proposed his Schrödinger's cat to try and show how ridiculous this was. But it does seem to be, and is accepted today by mainstream physics, you can't get away from the probabilistic element. There are arguments to this, I want to say. I'm not trying to be stuck in the past. There are modern arguments for and against. But we're going to take the physics of the time and what the maths seems to show. So if there's a probabilistic element, then that means causality kind of breaks down a little bit. A classical view of causality, one thing smacking into another thing. You can track it. It's beautiful. That's why people love Newtonian mechanics. You can map everything you want, and it works pretty much perfectly well. But when you have probability, you may have an element of acausality. That is, two things happening or one thing happening, but not caused by a thing previously directly in a cause and effect chain. Now, you'll obviously know that Jung was working on synchronicity around this period of time. He'd had the idea for a long period of time. Synchronicity, when you observe it psychologically, is a really strange thing when it starts to happen to you. It typically starts to take place when you begin a process of working with somebody else, say therapeutically, or you begin to take your own unconscious seriously. Very weird things will happen. These so-called meaningful coincidences that don't seem to take place via a cause and effect chain. Jung was refining his definition of synchronicity around this period of time with enormous help from Pauli, and thought that, well, synchronicity, it's an inner phenomenon. You can absolutely observe normally quite a strong affective charge, what Jung called the constellation of an archetype. And you also see effects in the outside world. That means that whatever is orchestrating synchronicity has to span both worlds. A psychoid archetype spanning both of these different things, but still fundamentally, at least how we observe it, psychological. So we have a probabilistic acausal element with quantum mechanics, quantum physics, and we also have it with synchronicity regarding the psyche. So what Jung's proposing with that new definition of archetype is, what if, this is a big what if, and this Jung always said this was a hypothesis, he never went further than this. What if whatever an archetype really is, when it's not in a purely psychological or even a purely physical form, spanning both of them somehow? How? We don't know. What if that is the ordering principle? That is the probability. That's a huge, huge step. To be fair, it's not that far off of the so-called Copenhagen interpretation of quantum mechanics, which essentially says that the observer of a system, of an experiment, whether that be the equipment or sometimes the conscious mind of the individual physicist, is somehow interacting with that system and causing a probabilistic potentiality to fall into an actuality. They're very different ways of looking at it, but they are essentially within the same ballpark. Does this mean that archetypes underlie quantum physics? No, it doesn't. They might, but both Jung and Pauli were very rigorous in their hypotheses. They were serious scholars, both of them. But at the same time, they both knew, as we know today, synchronicity needs to somehow be explained. And so too does the weirdness of quantum mechanics. This eventually, and this is in Synchronicity and a Causal Connecting Principle, this is the schema that Jung and Pauli finally agreed upon together as representing what must be factored in for a complete picture of reality, physics and psychology. On the vertical axis, obviously it shows indestructible energy. This is the formless substrate of all of physics that we can't literally see, but is required for absolutely everything. And down the bottom is the space-time continuum. This is the realm in which energy is visible through its transformations. And there's a kind of tension between these two things. There's a relationship between them. You could call them, if you wanted to, you don't have to at this stage, but opposites of some kind. And then left to right, you have causality and we have synchronicity, or the equivalent of synchronicity in physics. There's these acausal or probabilistic elements. So again, these are essentially pairs of opposites, not literally, but they appear to be irreconcilable with each other. In other words, by irreconcilable, how do these things literally interact? We don't know at the moment. That's all opposite really means. A paradox. Pauli preferred the term paradox, but he did use opposite as well. So how can you have a rigorous and non-metaphorical, that's important, theory that takes into account all of these things, in particular causality and acausality together? And this is where we're going to go very, very deep, and we're going to track what Jung and Pauli believed across time. The first obvious jumping off point is Plato, a Platonic world that underpins, or perhaps is all around, everything that we know of within the universe. A timeless world of forms, if we're going to take Plato literally. So everything that we see as being apparently disconnected in the outside world really is connected because it's emanating from or reflecting or embodying a form of some kind. If this is true, and Jung and Pauli both strongly entertained this, then you would therefore have a mundus archetypus, literally a world of archetypes that underpins both the laws of nature and the psyche. Jung said, yeah, that's possible. That might happen. But you can't prove it. It's impossible to prove. You can only really flirt with it. Now, Pauli was even more critical of a Platonic worldview. He says explicitly he disliked Platonism, and he also disliked fusions of Buddhism and Platonism. Why? Because they disregard the paradox of complementary pairs of opposites, such as, conscious and unconscious, or psyche and matter. Why does nature need to contain pairs of opposites? Why can't we just say that this is an artifact of our conscious mind, a lack of knowledge of some kind, maybe being in conflict or being in neurosis? Because of the effects and the reasoning behind the interaction of so-called pairs of opposites, things we don't understand how they interact, but an ongoing process of transformation comes about through their interaction. So the question, therefore, is, how do they interact? And what Pauli's saying is, if you just want to invoke some kind of Platonic worldview that does not explain how these different things interact or relate to each other, that's pretty much a slam dunk as far as I'm concerned. You can take a Platonic view of things, but wait a minute, how does that explain causality and acausality? It doesn't. You've just introduced an abstract thing that seems to explain things, but with another unknown. You have to invoke a metaphysical principle. So Pauli preferred Taoism, or an evolutionary model. That was another alternative, where consciousness interacts with an archetype or whatever it is within the unconscious that Jung and Pauli are really talking about on a continuous basis, so that everything is always in a state of being. These two worldviews, Pauli said, they're logically free from any contradiction. It's another thing with the Platonic worldview, Pauli says, why should the Platonic world at all want to collapse into time itself? Why should it enter into space-time? Especially when consciousness itself, Freud said this, Jung said this, Pauli agreed with this, is an extremely difficult thing for an individual to develop. It seems to be at one level contra naturam, individuation, the development and the expansion of one's own consciousness. It's extremely difficult. The unconscious seems to want, under natural conditions, to pull the person back into a state of unconsciousness for survival adaptive benefit. Why would a Platonic world care in that instance? Pauli keeps going. He also says that across the 2000-ish years of intellectual tradition within the Western world, he has despised the morality element being brought into Platonic thought, and then also the Christian developments on and incorporations from Platonic thought. He thought that the idea that if a thing or a person or a whatever embodied the form or reflected the form or represented the form, he thought that by saying that that made them more good in some sense, in a moral sense, was absolutely reprehensible, because it devalues the matter side of things, the natural side of things, and favors towards some kind of abstract, moralistic problem. And Pauli was very, very, very well aware of the will to power, a word from Nietzsche and then later Adler, in theories like that. Instead, he proposes automorphism. This is a mathematical term. It means self-structuring or self-similar transformation. as the signpost towards a neutral language. He also agreed with Jung that archetypes cannot exist outside of space-time. That's another criteria for building our grand unifying theory, let's say. They can't be outside of space-time. They can't be in some kind of broadly metaphysical place. If you do this, then you can never have a true unification of matter and of psyche, because something is always outside, right? There's a source which requires you to draw arrows on a diagram. If you're drawing arrows on a diagram, Jung and Pauli say, no, you missed the point. You're moving away from transformation, which is what we can see. In fact, Jung actually goes further, quote, such judgments are a relic of the primitive participation mystique. This was amazing when I first read that because it explained so much. What Jung means by that is you're under pressure, like individuation pressure of some kind throughout your life. And what a lot of scientists or traditional materialists, and by that I mean people who only see the material world and acknowledge literally science as being valid, psychology or depth psychology certainly off the table, religion, mysticism, all silliness and childish. What Jung thought was that these people had unconsciously spotted this archetypal inner-outer correspondence in the natural world, didn't realize it, but in their fascination with, for example, physics, they had offloaded that individuation pressure or the requirement for psychological maturity into the material world, and thereby, in the words of Levi Bruhl, entered into a participation mystique with the material world. Or in other words, they'd cheated in their personal development. And the same way when someone wants to abstract into a metaphysical realm, it's exactly the same thing, but flipping to the other opposite. Anyway, back to resolving this image. As the letters with Pauli continue, Jung proposes that you can only really unify matter with an ideal or an idea via a third medium, what Plato called the triton eidos, which Jung locates specifically in the psyche of the observer. We'll explain this with a quote. Nowhere else but in the psyche of the individual can the union be completed and the essential identity of idea and matter be experienced and perceived. Pauli eventually agreed with this after a little bit of pushback. Now, this doesn't mean that the psyche is the unification, but that the unus mundus, the one world, the underlying state of reality which our consciousness splits into psyche and into matter, requires always, because we're human, the perspective of being within the psyche. Even with physics, you cannot get outside of psyche. You observe, you think, you intuit. We're literally stuck with it. Even when you observe an experiment, as per the Copenhagen interpretation of quantum mechanics, psyche very well might be involved because we are stuck in psyche. Both of them agreed that psyche and matter were essentially mirror images of each other, and therefore there were two potential ways, the way in and the way out, psychology and physics, of potentially accessing this unified third language, or this triton eidos of Plato, or whatever it was that would unify these two different domains. And synchronicity was mega important because what does synchronicity do? It unifies and clearly shows a connection between inner and outer, a psychological transformation corresponding with an outside event. Both of them also agreed that it was number, or what was behind number, as we said, that would offer this linking bridge. Just as Pauli moved from 3 to 4 in the development of his exclusion principle, or Kepler and Fludd argued about being 3 or 4 as the key to the secrets of the universe, so the movement of 3 to 4 appeared in Pauli's dreams. And this led him over time to a very personal conclusion, that his intellect could go no further. Pauli was a very strange, unique individual in the history of the world. Quantum mechanics is only about 100 years old, and Pauli was one of the experts of the 20th century in quantum mechanics. But he also had very clearly, and you see it, it's mind-blowing in Atom and Archetype, those collected letters, that he clearly grasps analytical psychology, Jung stuff, extremely well. If you look at the different collaborators which Jung had across his career, you can kind of rank them. How influential were they on Jung's theories? Well, Pauli was indispensable for Jung's theory of archetype, moving beyond just the biological interpretation of it, and on the theory of synchronicity, and of lots of other things too, rather subtly. So Pauli was a unique individual, and his dreams, he writes about them in a lot of detail. His dreams seem to be pointing that out to him, that he had the psychology, and he had the physics. He was missing, according to Jung, an idea of a spirit or idea. We won't get into that here. But he was also missing something else, moving from 3 to 4, masculine to completion. And that fourth element Pauli derived, and he said that this was the discovery of his own personal myth, was human relationship. If you focused on human relationship, that would do two things. One, it would be the next step for his own individuation, the development of his own personality. And two, that it would be the sine qua non of grasping within, intrapsychically, the nature of the Unus, Mundus. In fact, Pauli writes to Jung that the main realization from this, apart from his dreams, came from the fact that he felt extremely lonely, like people didn't understand him or could relate to him because of the things that he knew. It's rather reminiscent of Plato's cave, strangely enough. And it's exactly what Jung said would happen when someone moves towards individuation. And Jung replied and said, I feel lonely too, extremely lonely. People seem to think I'm just an esotericist. And Jung had spent, I would personally say, about the last 20 years, 25 years or so, this is at Pauli's death point here, trying to get other people to take him seriously, because he should be taken far more seriously. But regardless, they both shared those sentiments together, and their final conclusion was biology, chemistry, physics would show us the outside world, and analytical psychology, depth psychology broadly, would show us the inside world. But in order for us to grasp the true nature of the Unus Mundus intrapsychically, the only thing we can really truly do was a sense of individuation. Although Pauli was extremely optimistic about the future, he wrote quite extensively to Jung that, and this sounds like a man who's become happy with his myth, the contributions that he's made, enormous as they are, and the open questions that result from his work. He said that in future, different scientific fields, I'm absolutely sure, will offer us a way into this underlying unifying nature of reality. In particular, he highlighted biochemistry. Sometime in the future, biochemistry would unlock the laws of life. He predicted they'd be different and not rely on, as in a one-to-one correspondence with quantum mechanics. And somebody or a group of people or people in general would apply that to the theory or the archetype of number and of analytical depth psychology to get another angle in at the Unus Mundus problem. As far as I'm aware, no one's really doing that at the moment. No one's really tried. So if you're into biochemistry or an adjacent field, this is an open question for you to potentially take on. That would be exciting. Pauli died in 1958. This was 3 years before Jung, despite him being unfortunately 25 years younger than Jung. And the story goes that on his deathbed, he was speaking to one of his good friends and colleagues, and he said, "Did you see the room number I'm in right now? It's 137. I'm never getting out of here alive." And he was right. There was the mysterious 137, a number which was discovered in 1915, which Pauli had been preoccupied with for a very long period of time. Why 137, or really 1/137, as the fine structure constant necessary for the entire atomic world to be held together? And it's rather beautiful to see that that is exactly the domain in which he was working with Jung. What is the unified language between matter or the material world and psyche? Is it the archetype of number? Because Pauli thought that it was. And therefore, 1/137, is that going to be a part of it? Is there a special code? What the old alchemists might call an imprint from the mind of God, or a fingerprint left from the mind of God, with more discoveries left in store. Something I've never seen mentioned about this very famous story of Pauli's death is, well, the room number was 137. The fine structure constant is 1/137. So I was looking at it and thought, that's the reciprocal, literally the mathematical term for flipping a fraction on its head. You move from one opposite to another. If this was truly a synchronicity, as lots of people believe that it was, and it seems to be, was that maybe, can we infer that Pauli was moving from one opposite to another, moving from life unto death, or perhaps, who knows, what death has on the other side? All we can really do with a story like that is to be amazed and in awe of something like it, if that's our inclination, but also to have a deep respect for someone who was a genius in physics and had the courage to confront himself and his own issues of maladaptation, something not many people do to that level of seriousness, and also was so multidisciplinary and courageous in that fact that he moved into the more esoteric Jungian psychology, and in so doing has produced a body of work with Jung that, as I say, my opinion, has yet to be surpassed. These questions are here for the future to pick up and carry on. We've reached the end of the video. I believe that's all we can reasonably include in a single YouTube video on this topic. Though to be fair, we are absolutely going to continue looking at Jung and Pauli as these videos continue, because there's so much more we haven't had a chance to speak about. But I really want to close this off by pointing out something that some of you will be aware of, others won't. And it's the people who aren't I really want to communicate this to. Because if you've made it to this point in the video, I'm going to bet one of two things. I believe that this is going to be true. One is you have a very deep but maybe unconscious yearning to be part of some kind of tradition, to feel like you're capable of contributing intellectually, and that this heritage, if you like, is yours. Jung, Pauli, and all these other ideas can be passed on to you in some capacity. Or if you've made it this far in the video, you've been smoking something green, or both. But if it's the former, I really want to say to you that Pauli in particular looked to the future. He seemed to have become calm and at peace. He found his personal myth, and he explicitly said, this work will be continued on in the future. And regardless of whether or not you have a university degree or not, please feel that you can take up that work and carry it on yourself. Because as I say, not many people are even attempting to do so seriously. Again, some people who are more psychological or psychologically informed don't attend to the physics or think that physics is some kind of metaphor when it is not. You need the physics and you need the maths. So learn it. Or consult with someone who knows it. Obviously, Jung and Pauli collaborated. It shouldn't just be a solo endeavor. And then also learn your Jungian psychology as well. And again, in the age of the internet, people are fully capable of doing things like this if you're motivated. But sometimes people need a bit of encouragement. That's what I want to communicate on that front. And that is why, again, sorry to mention it again, but that is why I'm working on the Jung project. So that if you want to brush up and take your Jung knowledge as deep as possible, that is literally what that is there for. It is not for people who are interested in summary videos that are very surface level and tell you how you can integrate your shadow in 4 easy steps. None of that. It's pointless nonsense. This is for people who want to study and apply very, very seriously. If you're into that kind of thing, again, the link is down below. But thank you very much for indulging me today on all of these weird and wonderful topics. I really appreciate it. I'll see you again soon in the next video.